Vector Calculus 3 Integral Theorem. This is a crash course of vector calculus, good for learning, taking this crash course before you take the class in the college, or you just listen this as a kind of review after you learn it. Okay, the important things here is to understand the meaning and why meaning of each derivatives and the integral and why such a thing is defined. And as I said in the video 2, most of them come from the demand from the physics and engineering. Okay, and math can go off all kind of different kind of derivatives and integral, but if not used, then it's kind of standing alone and not much. It's not in the book or anywhere. Okay, so it must have some kind of use in the physics. Now, we talk about gradient, and the gradient f generate gradient phi, if it's a potential, generate a vector, the force vector, right? And here in this example, it's E, electric field. Okay, now you have a dr. The dr is a segment of the moving direction times E is going to define dw, and w is a work, and you take an integral from A to B, the point A to point B. So this gives the potential difference. We call potential energies, right? Potential difference between point B and point A. So we take a line integral of this function, gradient phi, line integral. Then we can find out the potential difference. So when the phi function is given, and in this space we know how trajectory goes, we take an integral along the trajectory, then we know how much potential energies changed. For example, potential energy is 200 here and 100. So we know 100 potential energy is consumed, and that changed to kinetic energy. Okay, so when we have a potential field, we can calculate by taking a line integral the differential of the potential energy in two space. Okay, so that's a gradient integral theorem. Okay, next one is a divergence theorem. Do you remember in the video 2 I mentioned that divergent vector, here is E, shows that increase in flux, right? So if the electric particle is distributed, each particle is going to generate new flux. So from here to here, the amount of flux increase. Okay, that's the divergent E. And how much it's increased? Well, you take an integral over closed circle, area ds, right? The flux, how much flux is coming out. Okay, then we can tell how much the vector flux generator inside a closed circle, which is this. Okay, because divergent E, it tells you the amount of flux generator, and this flux generator, you take a integral by volume, then that's the amount of the flux coming out from this closed circle, which is E integral by surface. So second integral is going to be equivalent to triple integral. Okay, so this is divergence integral theorem. Okay, so this is often called Gauss's theorem. Okay, it's a very fundamental theorem used in electromagnetic theory. Okay, now Green's theorem. Green's theorem is a mathematical theorem. Suppose you have fx and gx, and enclosed from here to here is gx, and from here to here is fx. So if the field function, okay, you calculate along this ds, dx, dy. Okay, so it's going to be same as this line integral of enclosed circle. Okay, you do that for each component. Well, Green's theorem proof is everywhere. You can go through this. If you add them up, it's become nicely that it's going to be, this is a curl E. So the curl E integrating on the closed surface is going to be same as the line integral. What it means is, suppose you have E along with this line dr, you take integral of this closed loop is going to be same as, this is a ds integral of curl E, and curl E is related to magnetic field. So is magnetic field, the total amount of magnetic field inside the closed loop is related to electric field circling around the enclosed surface. Okay, so that's the equation, integral equation about the curl. So, here's a picture. Suppose you have the vector E, you take an integral along this closed loop, then you can calculate the curl E integral, total amount of curl E, which is related to magnetic field. Okay, so that's the way in physics, magnetic field and electric field is related, and this equation basically it's Green's integral theorem, shows this relation, magnetic field in the electric field, and that becomes a part of Maxwell. Okay, the Maxwell's equation
Okay, afternoon 2 o'clock.
Okay, thank you.
Okay, thank you. Okay, bye-bye.
Maxwell's theorem, there are 4 equations. 2 of them is Gauss theorem, and 2 of them is Green theorem. So if you master this math, basically electromagnetic theory is going to be much easier for you to master. Okay? So this is a very quick rundown of the integral theorem of the vector calculus, and if you like, hit the subscription.